So, hello guys, good evening, good morning, good afternoon, everyone. So, if you're currently on the call, please go ahead to drop a message on the Discord channel so that more people will join the class. Meanwhile, you can go ahead and follow us on Twitch if you're yet to follow us on Twitch, and subscribe to our YouTube channel if you haven't subscribed to the channel. So basically, we have our instructor for today on the call, Emmanuel Anand. He's a software developer and he's from Greater Accra, Ghana. So welcome, Emmanuel.
Yeah, thank you. Thank you.
All right.
Trying to-
So you can go ahead and share your screen.
Sure. Kindly give me a minute. Let me share my screen.
All right, that's fine.
Apologies for the delay. Sorry.
No, no problem.
Okay, is it up?
Okay. I think I just okay. Yeah, can see
Okay,
it.
so all right. Thanks everyone. My name is Emmanuel Anan. Like I was earlier introduced, I'm a software developer, and today I'm going to be taking you through API security and authentication. So, after by the end of this lecture, you should be able to secure your API with SSL. You should be able to implement some basic authentication and also validate your input data. So the first question is, why do we need to learn this at all? Why not just write our front end, hack up our back end with CRUD operations and just move? The reason being, data data is very sensitive and it's very important to a lot of people. So you don't want your data falling into the wrong hands. And so we need to prevent data breach, because as you can see, an example is something that happened to LinkedIn, I think 2021. Their information, their data got leaked, and someone was making some good cash out of it. So someone will end up losing their job or something like this. We don't want to do this. We want to prevent hackers from getting access to our data. I want to make it more difficult for a third party to access data they're not authorized to access. So the short answer is, we are trying to implement security to prevent data breach. So there are different ways of implementing security. Now we're going to take this implementation at the application level, right? There are different levels on which you can implement security, but this lecture will be focused on at the application level, what you can do in your application to secure your data, right? So these are just three of the things that you should do. There are others, but these are the basic ones that you most definitely should implement. So the first one is the encryption, second one is authentication, and third is data validation. In no particular order, but yeah, you would want to make sure your data is encrypted and you are implementing some kind of authentication and can validate your inputs data. Right. So the first thing I'm going to take is encryption. Basically, encryption has to do with not sending your data in plain text over the internet. So if you don't implement some kind of encryption on your system, what's going to happen is, imagine someone just logs in, provides their email and password, and everything's in plain text. A hacker somewhere will just be on your network sniffing and will be able to get your packets and read the person's username and password. So it makes you very vulnerable. Or imagine you're trying to make an online payment and then you provide your card details, and someone, a hacker somewhere, can just see this thing in plain text. If this happens, you are losing a lot of money. So you want to implement encryption, right? So to prevent hackers from seeing things in plain text. So this encryption is implemented using SSL or TLS. Now SSL is the older version of TLS. TLS is a more upgraded version, but the term SSL has come to stay and people use it interchangeably. But yeah, so basically it's a protocol for encrypting internet traffic. So it's meant for two things: the SSL, one to encrypt the your internet traffic so that your hacker doesn't see the things in plain text, and then two to verify the server's identity to know if exactly the server is who they say they are, right? So for the SSL, there are two ways you can have your certificate. You can either be signed by yourself or it can be signed by a certificate authority. Now the recommendation will be to use a certificate authority to sign your certificate on the production environment. And then if you are doing some testing or you have some internal network that doesn't have any sensitive data, you can also self-sign it. So let's look at the self-sign certificates. Basically, these ones are unsafe for public websites. So if you are going to have any kind of service online and it's going to be open to the public, you most definitely don't want to use a public SSL certificate. You want to use one from a CA, that's a certificate authority. And yeah, as I said, they are used for testing and low risk internal sites. Now, the advantage of using the self-signed is that it is fast. You just run a couple of commands in your command line, which we'll see later, and that's it. You get your certificate. It's very fast, and it's free. You don't need to pay anything for it. Whereas the one signed by the CA, it's not free. You have to pay something for it. So another advantage is both of them secure data anyway, but the one issued by the CA has a higher degree of protection as compared to the one you do yourself. But either way, your text is not going to be in plain, your traffic is not going to be in plain text, which is the goal. But you should know when to use the self-sign one and when to use one from the CA. And the disadvantages, yeah. So if you've come across ever using a website where you are you are asked, yeah, you are notified that the page is not safe, right? And if you want to continue at your own risk and all of that, it's just because the site is not has not been secured with SSL or TLS, right? So if you don't do that, you always have that prompt. Your users will always have that prompt, making you look like you are a malicious website. You never trust a website if you're not certified by a CA, right? And you also don't have that padlock sign on your next to where you input your URL, right? That padlock sign shows that yeah, the website is secured, right? So yeah, that's for the self-signed. And then we go to the CA issued certificate. Now for the CA issued certificates, there are various levels of encryption, and every level has comes with its own price. There are about six of them. I just have like two here just to show an example of what some of them look like. And then you need to know, um, you need to be able to choose which one fits your criteria, right? It's not all of them you need, it's not any of them you need. You need to know what they do and know which one to choose. An example is the EVSSL, the Extended Validation Certificate. So that's like the most expensive one CA issued certificate, and you can it's basically used for high profile sites like anything that has to do with financial data, right? um Anything is really going to be costly. Is more like is the highest you can get basically, so it's very, very expensive, and you should be using this if you are dealing with very sensitive data. The next one to look at is the DVSSL, the Domain Validated Certificate. Now that's the cheapest, right, and it's the fastest to obtain. The EVSSL can take maybe 3 to 6 days, and the DV one is just in minutes, right? You just get it ASAP, right? So that one is cheaper, and as usual, the cost is that the level is low. The level of the encryption is low, right? But it works. It works for sites like blogs and any other website that doesn't take user information, right? um something that has to do with like just posting articles online. You don't have to sign in, you don't have to do anything, just a website. Those ones you would want to use the domain validated certificates. Well, there are others. There's a wildcard SSL. So those ones are for, someone might ask, what about buying like one SSL certificate and using it for different sites? There's an SSL certificate for that. This one is for, the wildcard one is for usage on subdomains, right? So if you have like multiple subdomains, you can have something like mail.com and any other subdomain. You can just get one wildcard SSL certificate and then use for those ones. So these are just an example of the few ones. You just need to know what your project is about, and then know the ones to choose, and also know your funds, basically. So next, I'd like to take us through the TLS handshake. So basically, before your browser is able to communicate with your API, there's some prior conversation or communication that goes on, right? So what happens is, if you enter the name of the site you are trying to visit, if something happens prior to you seeing the resources, is that your browser is going to send a request to the server, asking the server, hey, identify yourself, right? Who are you? And then the server will come back with either a certificate and a key, or come back with neither. If it's not, if it doesn't have TLS on the server, it's come back with nothing. If it does have TLS, it's going to come back with the certificate and a public key. Now, when the server comes back with the certificate and the public key, the browser is now going to check with the certified certificate authority, right? It's going to kind of submit your certificate and have them approve if that is authorized or not. Very similar to handing over like an ID to, say, a policeman or something. They have to verify, because you can just go and print your stuff and make things up. So they have to verify. And then the additional benefit you get from using a CA is that when you are trying to request to get the certificate, for some of them, you are going to have to go through a lot of scrutiny, right? Well, not a lot of scrutiny. You have to go through some processes to verify that the domain you are trying to secure is indeed yours, the business is yours. So they do some background checks, basically. So if the CA can say, oh, we've seen this certificate, we approved this, we issued it, and we trust the person is coming from, then you can know that nobody is trying to mimic another service, basically. So if CA says, yo, this certificate is good, then you know you are safe, basically. You are encrypted, and the person you're talking to is the person they say they are, right? Because some people can actually impersonate other service and try and be like a man in the middle, sort of. Yeah. So if the CA approves, what's going to happen is that the server is going to use its public key, the public key that came with the certificate. It's going to use that public key to encrypt the browser's symmetric key. Before I even proceed, let me just give a quick overview of what a symmetric and an asymmetric key is. A symmetric key is just a key that is used to decrypt and encrypt data, right? The same key that was used to encrypt the data is the same key that will be used to decrypt the data. And then for asymmetric key, one key is used to encrypt, which is the public key is used to encrypt, and only the private key can decrypt it. You can't use the public key to decrypt what you encrypted with. It doesn't go the reverse way. But for the symmetric keys, you can use the same key to encrypt and decrypt. So what's going to happen is that the server gives its public key to the browser. The browser uses the public key of the server to encrypt its symmetric key, right? And sends the symmetric key over the internet. Now, any hacker that intercepts the symmetric key cannot decode it, because the hacker doesn't have the server's private key. So in that way, it is safe in transit, right? So it gets to the server, then the server decrypts the symmetric key. Now, then both of them have the symmetric key, and both of them can communicate. So that's what happens in the TLS handshake. So yeah, I was going to show a quick demo on some of on this. Okay, so I have. Ooh, I'm not sure if you can see my screen. Hopefully, you can.
Yeah, we can see your screen.
Okay, so you can see the code, right?
Not yet. We're just seeing your overall screen. So now you're seeing your code editor.
Ooh, okay, let me do this again. Can you see it
Okay,
now?
we can. Yeah, we can see your code editor, but you need to zoom in a bit.
Um, how do I increase this font? Come here. I think I'll just have to go on with this. I'll share the code to my GitHub repo after you can take a look at it.
Oh, hold up.
Is this better?
This is no better. Give me a minute. Emanuela, do you know how to zoom in on the code editor? I think she should. So they say Windows key then plus to zoom in.
It's not doing anything.
So the
Or
Windows
you can just
key.
go straight to appearance. Can you hear me,
Yeah, I can hear
Amaka?
you now.
Yeah, we can hear you. Ella.
Can
Go
you go
on.
to your appearance on your VS Code? You can increase it from there.
You can still see my VS Code.
No, I can't see it. It's blank.
No, it's blank. Okay.
Can you see it now?
Yes, we can.
Can you see appearance from there?
How do you exit the presentation mode?
It's so
Okay.
tiny. I can't even see. Amaka, can you see it at all?
Yeah, I can see the
Uh,
appearance.
Can you see appearance here? Can you see? You can increase it from there.
so
I only see I only
what
see
is
presentation mode, distraction mode, exit full screen.
Or please just press Control and plus, so that is quicker.
Can you
no?
see
That was
this? It's out of the screen. That's
Press your
still
yeah. It's
visible.
Control
better.
key and plus.
Just zoom in a bit. You went too far.
Yes. Do it again, please.
It's just between 100 and 200. I can't get anything in between. This 200 and this 100.
Oh, okay. Well, can you try this? Someone is saying your Windows tab and plus.
Yes, same thing. It takes me to 200, which is too big.
Okay, I think this is better. Okay. Oh, okay.
It's still very tiny.
Well, it's even a little bit big. Okay.
What can I do about this? Okay, I'll I'll just show this in um
Okay, I
Notepad.
think we'll just use it like this.
This bigger.
Give me a minute,
Yeah,
please.
this is better. This is better.
Yeah, let me
Although
just
it's
use
a
this
little
to
bit
explain.
small.
Then we have
Okay,
to
it's bigger.
manage with
Yeah,
this.
we'll just manage this.
Okay.
It's okay.
Yeah, so basically it is a very simple node project that is not even using any framework. I'm trying to demonstrate how to create an SSL server, right? So we need to um, require the model to use the HTTP server model and just create server and then pass in your the path to your key and your certificates. I think we've spoken about the certificates, SSL certificates, and we spoke about the key. Now there's a private key. but I'll show you how to generate it soon. But then you just pass in a path to your key and your certificates, and you create your server. If you use the HTTPS model and you don't pass in a key and a certificate, you've not secured your server. It is still going to be um, readable in plain sight, basically. So you have to pass those in. And this one basically returns a hello world from secure server if you make any GET request to the server, right? Um, I already have like a screenshot of the outputs. So we'll just go faster. Let me just bring that up and you see what it looks like if you don't have SSL. Yeah, so if you don't have SSL and then you try to hit the endpoint of the code, what's going to happen is that you're going to see the hello world in plain sight like this. So if anybody is on your network and is sniffing your packets, the person sees this thing. So if it happen to be your card details, happens to be your credentials, is exposed, right? And you don't want this. And this is very easy to do. Very, very, very easy to do. Doesn't take any sweat. So imagine someone who has the motivation to do this. And this is what is going to look like if you've secured it with SSL. So you can only see this information that you can see. Some parts are gibberish. You can see an email address, you can see like a location of sorts and other stuff. They are what you use to sign your SSL certificate, right? But you can't see the actual data. It's the same data we are returning, right? The hello world from secured server, but you can't see it because it has been encrypted. So if there's a hacker on your network and he gets this, makes things a lot more difficult for him to figure out. So this is a quick demo of what that is going to look like. Back to the presentation. Yeah, so that was a quick one. So I showed you how to use the node to build a secure website, but I didn't show you how to create your certificate and how to create your key. Now these commands, I'll advise not to chew them basically because they change all the time. Basically, I'm using OpenSSL to generate the private key. Right, you can just go to OpenSSL docs and then check out the flags and the options. But basically, this one is going to generate a private key. The out flag is the name of the file. So it's going to create a file called key.pem. It's going to the second command is going to create a request to create the certificate, right? So when you create a request to create the certificate, you'll be asked a number of things. That's when you provide. That's where I provided like my email, my location, and other stuff. So if it was signed by a CA, they will ask for similar stuff to prove that you are who you say you are, basically. But then that's where I added those information I showed you in the encrypted stuff. Basically, creating a request with the key that you created previously, the private key you created previously. So you are passing in using the dash key flag, and then the name of the output file, basically. And the third one is when you actually create the certificate. In this command, we are passing in a very long time for it to expire. The 9,999 is how long the key should be active till it expires, right? And just these three commands will give you the output you need. It will give you your key and your certificate, and they look like this. I want to show you what the file looks like. So this is what the certificate looks like. If you open the file in like notepad or something, this is what it's going to look like. And this is what the key also looks like. But it's going to be generated for you. So if you run those commands that we saw in the command line, you are good to go. It will generate it for you. Then you just have to add those files in your directory. your projects directory. You just have to add them, and then you just pass them as a path, like I showed you in the Notepad plus plus. You just pass that path to your you pass it to your server, and you're good to go. So the next thing is the authentication. So we've seen what the SSL is. We've seen the different types of certificates we have, the private and the public. Now we're moving to authentication. How to authenticate your API. So at this point, you've been able to make sure that whatever data is being passed from your front end to your back end is not in plain sight. But what we have not done yet is we've not yet um put restrictions onto our resources, like who is able to access our website. And out of the people who are able to access our websites, who is able to do what, right? So basically, you can think of it, you can think of authentication and authorization in this sense. If you have a friend coming over to your house, right? Your friend is allowed to go to the hall, but your friend is not allowed to go to, say, your sister's bedroom or your parents' bedroom, right? Your friend is authorized to come to your house, authorized to use your hall. He's not authorized to use your parents' bedroom. So even though you can allow the person to use your API, you have to restrict them from viewing every single thing. Some things are allowed to some people and not allowed to others. So for the same analogy, if a stranger just comes to knock on your gate and says, "Hey, I want to sit in your room and watch, I want to sit in your hall and watch a movie," that's going to be weird because they're not your friend. So every rule has what they play basically, and that's the authorization. Basically, are you authorized? Are you allowed to do A, B, or C? Then the authentication is, are you allowed to even come in at all, right? And to implement this, we use something called a JWT. That's a JSON Web Token, right? So you can also um, picture the JSON Web Token like yeah, I like swimming a lot, so I'm using this pool analogy. We have this commonly here. So if you go to like a pool and you want to swim, and you go and you pay whatever the amount you're asked to pay, the person taking the money takes the money and gives you some kind of identifier, right? It's like a wrist band of some sort. It's colored to indicates that you've paid and you're allowed to swim. Now, if you have that wristband, you can even leave the premises, go anywhere, come back. As soon as they see, they know we've already authorized you to use our pool. We've already gone through the process of making sure you are okay and allowed to use our pool. So whenever you come back, they just check the band. If it's there, it's smooth, right? So that's how the JWT happens. If you authenticate a user, you give the user a kind of band to identify the user. So whenever they come again with that same band, we've already done the work of authentication. You don't have to waste time and now try to prove that the person who is coming is not a hacker, is someone we know, and all of that. It makes, yeah, you're able to visit the sites, and then you're able to get access to whatever you are allowed to view, right? So that's a JWT, and we'll see how to also make that and sign that. um so yeah, that's it, and we go to another demo. Is this any better in terms of size?
No, it's not.
It's still
Sorry, I
small.
have a question.
Okay,
Sorry, I didn't get your name. Are you using VS Code or another code editor?
I'm using IntelliJ.
Oh, okay. Uh, could you try the command again? Control and plus, because for VS Code you could directly increase the fonts from appearance, but it's not working for you. So I don't know if you could try the Control and plus if it's going to work
Yeah,
since
it
you are
does
using
work.
another code editor.
It does
Okay,
work.
but
It's
it's
just
really
giving me,
really
yeah. Let me use
yes,
VS Code.
yes.
Let me try and use VS Code. I think I
Yeah,
have VS Code.
please, if you can, thank you.
So what did you say the command was?
Use Control and plus, or you just go to view. I don't know if you can see view on VS
Yeah.
Code. Then you see appearance. Can you click on
Mm-hmm.
appearance? Then zoom in. Zoom in. It's supposed to work.
Oh, nice. Control n equal to. So is this better?
Yes, this is better.
Okay.
Should be
So
better,
yeah,
yeah.
we have this also small projects trying to demonstrate authentication, and it actually also has the HTTPS and the TLS thing enabled. So same stuff. We are using the HTTPS model. We are using the FS. We are passing a path to our key and our certificates, and then we're using that to create the server. So that's exactly what's. So I just removed that part into the other project just in case you didn't see that one. It basically had this stuff, path to our set and our key, and then just pass it to your server, right? So this time around, we want to implement authentication. So I have, starting from my server.js, I have a number of endpoints. I have the endpoints. I've categorized them into two. Basically, I have one for authentication and then one for accessing any other information on the API. So if you hit my endpoints with a slash admin, you are served with an admin route. Whatever is there, I just I'm just passing in a string. And if you hit the basic route, you get the basic stuff. If you hit a logout, we are going to clear the JWT, but we'll come to that later. But yeah, this is the resource, the main resource I want to have on my app, and this is the endpoints for managing the authentication, right? So if you want to, so basically, if you hit my API.auth, it's going to route you to this guy. If you are doing a login, we are basically ending up here. So the code I have right now is that for the login, I want to get the request body. We are logging in with the username and the password, right? So when you log in with the username and the password, we are doing data validation. So this is the third part that we were going to do, but I've already implemented a very basic one. We might not have time to cover it, so I'll just quickly go over it. So basically, data validation is done to make sure that whatever data is being passed from the user is what you're expecting it to be, at least in the right format. So, because for one, some users will pass in the wrong thing because they don't know better. Others would intentionally try to exploit your API, right, to find vulnerabilities for SQL injection and whatnot. So, you want to do some validation. Some basic validations you can do is to make sure, for example, if someone is passing an email, it's not empty. The person is actually passing an email. The email has the at sign, it doesn't have some weird characters at the end, and so on and so forth. And for those ones, they are very common um regex expressions that can catch those things. So you don't have to think too hard. It's just a quick Google search away, and then you get a regex expression that's going to try and match the format of an accepted email, right? And then use that to validate. So if anyone is sending anything weird, it's going to catch it there. Same for a username or whichever field you are passing. Always make sure you are validating it. Always make sure it's coming in the right format, because it's very easy to do some SQL injection and crash your system or delete your tables. Really easy to do that. So yeah, I'm just doing a very basic one to make sure it's not empty. Basically, if it's empty, I'm asking them to provide both a username and a password. It's also um something that is It's a best practice basically to not separate, to not tell the user deliberately which field is wrong, right? So you don't tell the person the username is wrong, or you don't tell the person the password alone is wrong. You just tell them both are wrong, because it can make the hacker's job easier. So if I enter a username and I'm entering a password, and then the response is that the password is wrong, I know the username is registered in the account. So it's a matter of figuring out the password. So I've made his job easier. Whereas if I had said that, if the server says that um either the password or the username is wrong, now the hacker has to figure out which one was the right one, which one was the wrong one, right? So it delays the whole process, right? So I'm sure you've come across, personally I have come across some sites that I entered the wrong credential, but I didn't know which was it was, and then they're telling me it's either the password or login, and I'm like, just tell me which one, so I'll know which one to provide. But yeah, it's actually intentional, and for the reason I just gave. So that's what we have there. I'm wrapping this in a try, because anything can happen. I'm making a call to the database. The database might be down, the connection might be, anything can happen basically. So I'm trying to catch any exception. Um, so this is a login. So I'm using MongoDB actually. So I'm trying to find the username in the database. If there's no user, we are responding with the login not successful and user not found. If there's a user, we want to compare the password they are providing with a password we have. I'll come. I'll explain some more details about this soon. I want to explain the password they gave us against the password we have. If it checks out, if B compare says, if B crypt says that they are the same, and we're going to sign the JWT. So the JWT we spoke about. So if you log in successfully, at this point, we've verified that the person's email is in our system. We verified that the password is what we have. So at this point, we've authenticated that the person is allowed to use our system, right? So we need to give the person the band so the person can come back anytime. So a common thing you find on a JWT is how long should that um, token be valid. You don't want to give a token that lives for too long, right? Because basically, if someone has access, someone has, imagine you go to a cafe, right, and you sign in on your account, and the system is very secure and sends you the JWT, and the JWT is supposed to identify you. If someone else can get access to your browser history and view your cookies, and the person is smart enough to know what the JWT is in the cookies, they can use to impersonate you. Basically, it's very similar to if you went to the pool to pay and you're giving the band, you go out, remove the band, and give it to someone. Or maybe you are going home, you take the band off, you throw it away, you don't discard it properly, you just leave it on the floor. Some area boy comes, sees it, ties around his hand, and goes and says that, hey, I paid, allow me to swim. The person who is validating or checking that if you have your band, you can swim, would let the person go ahead, right? So you have to be careful not to make it last too long. Basically, let it expire. Um, right now I've set it to 3 hours. So after you do that, you are going to sign the JWT. Now, when you're signing a JWT, it's very common to add some kind of information in the key, right? You're not just going to give a random token and just leave like that. You actually put some information in there. Never put a password in your JWT. Nothing that is very important. Something you basically are signing with something that can identify a user by maybe an ID or a username, a random ID you are given, right, or username or a rule. In this case, I'm using a rule because my API allows admins and basic people to log on. So basically, there are endpoints that are open for people who are signing as an administrator and endpoints for people who are not signing as an administrator, right? So I have the rule also in there. So I have this information and I use a JWT secret. Now a JWT secret is a random string that you decide what it is basically. You get to choose what the random string is, and you are using that random string to generate your main JWT. Right, so I want to show you the secret I'm using. Yeah, basically this is what my JWT secret looks like. You can generate it yourself. It's not, it doesn't have, this one doesn't have any extra meaning to it. It's just, they're just random numbers I'm using, random characters I'm using, right? That's a JWT secret. And then you pass in the time to live, basically how long the token should be valid for, and you pass the token in the form of a cookie. So the cookie is going to be like a very small storage area where it has like key value pairs, right? So the key is the, I'm using the key. You can decide to it to be whatever you want it to be, but I just named it JWT, and then I'm passing in the token. And there are extra stuff, extra options you can set on the cookie, right? Whether it should use the secure as true, whether it should be passed using HTTP only. These all these things have meanings, right? It's just a quick Google search to find out exactly what these control flags do. But yeah, so basically we've signed our JWT with uh, data in it, and then we are passing it into the cookie and sending it back to the browser. So at this point, login was successful, right? If it wasn't successful, I'm handling that as well. If any exception occurred, I'm also catching that. So this is doing the login. We're going to do a very similar thing for registering as well, right? Yeah, gets the username, password, the rule. Yeah, I'm also doing some basic validation, making sure that my password length is not less than the number of characters, basically. Yeah, so this is what I wanted to show you. This was important here, the hashing. So there are different ways of authenticating, right? You can use like OAuth, where you use a third party like Google to authenticate a user, and that one is faster. But for the purpose of learning, we are going to implement our own. We're going to handle our own authentication by using a username and a password. But to do that, you need to make sure you're not storing your passwords as plain text. You don't store the actual password in the database, right? You always encrypt your password you are storing. So we are going to use a hash function, and that hash function is in the bcrypt module. So you use that hash function, pass in a password and something called a salt. So the hash function is such that for every character you give the function, is going to produce the same output, right? If you give it maybe AB, it's going to produce 16 hexadecimal characters, and they'll always be the same for the same inputs. So if you don't add the hash, what can happen is that if two people happen to use the same password, realize we'll have the same hash. If a hacker gets one person's password, it's very easy to use that to find out all the other people who are using the same password. Some people can end up using a password like flower. You can have like plenty people using a password like flower or something. But if you add the hash you are generating the salt, sorry, you are generating the salt yourself. So you are sort of changing the user's password. Whatever the password they bring, you also create a salt and add it and then change it. So no two people have the same hashed password, and that's what the salt does. And this is the number of times to hash the password. If the number is too much, you slow your stuff down, right? But it's going to be more secured because it's going to hash and hash the hash and hash the hash like that, basically. So I'm keeping at a 10. If it's too low, too, it's less secure. So you just have to find a good balance. If this you're able to hash your password with the salts, we are creating the user, adding to the database, and then we sign the JWT as we did with the login. So yeah, this is basically the authentication and then the validation. And let's just put this to practice and see. Okay. So I have the server running on port 8000, and I have my postman. That's a client that's going to be making requests to my backend, right? So as I said, I have this set of routes. the slash admin and then slash basic routes that are going to host the actual resources, right? So if you try to access this one without logging in, it will tell you that you don't have the right access. So this is the one for the basic, and this is the one the route for the admin, right? So let's try and access a resource from there, and it says you're not authorized because there's no token. You've not come with the band on your hand, basically. So we don't know who you are. You're not authorized. Same for the basic. We don't know you. But if you register, for instance, I'm registering someone, passing the username, password, and then the role, right? So I'll call this test 4. Give it a password 12345 6. Let me leave it as an admin role. Then I register the person. You see if it's successful, you see the response here. And the most important thing is the JWT in the cookie, right? So if you check this tab, you can see the cookie that we added. The key was JWT and the value was the token itself. So this random string has the person's ID, has the person's role, has the person's other stuff, right? So this is what we signed basically, and this are the options that we accepted on the cookies basically, and this is the time to live, how long for the cookie to expire. So if you have this in your browser, so anytime you hit the endpoint, this one is stored in your browser, right? So if it's if you make the expiry period very long and someone is using a public space to access their stuff and they get access to this thing, you can just copy it, Control C, and then you can just create add a cookie like this, and then you just paste it. If you paste and you make the request and the cookie is still valid, it's not expired, Ebefa, I mean, the person will be able to log in. I've messed up my cookie. Okay. Hopefully I have another one. Yeah, so that's it. So you should make sure it's not long. Make sure also on the part of a user, make sure when you are using any public network you log out because of something, some of these things. Very, very easy to for someone who wants to do stuff with it to get access to it. Let me just wrap up. So we have a cookie. We can just use a cookie to log in. In fact, say you can use a cookie to log in. You can also now access. This guy was an admin, right? If we try to access the basic, it's going to tell you are not authorized. So this is the authorization. Even though we are logged in, we can't access anything that is basic because we are admin. Actually, the admin should be able to access both. But for now, I've just made it admin for admin, basic for basic. So the admin should now be able to access the admin's routes. And that's it. We've implemented JWT, implemented some validation and some authentication. And I think that brings us to the end of my presentation. If anyone has any question, I'm happy to answer questions.
Okay, thank you so much, Emmanuel. Okay, the question is being displayed on your screen. You can pick it up from there.
Okay, so do I need to do all this TSL key generation before hosting my backend on a live server, or does the server take care of it behind the scene? You have to do it yourself. You The server will not secure your API for you, but you need to have the server in place, right? So you can do your so you are talking about going live. So at this point we are in production. So you have your API app. If you host it without doing the TLS, you realize that anytime anyone wants to hit your API, the person is going to be told that your site is malicious and it can't be trusted. So you have to do it yourself. Basically, the short answer is you have to do it yourself. No one is going to do it for you. Any more questions?
Yeah, okay. Next
Please, can
one.
you make the source code available? Okay, so I'll share the link and then you guys can have it.
All
My
right.
GitHub repo is public, so you can have it. Can we use local storage instead of cookie to store the token? You could use local storage. The advantage of using the cookie is that it's automatically sent with every single request. If you are storing it in a local storage, you have to handle actively adding it to your payload, right? So anytime you're making a request to any endpoint, you have to write code to add it every single time. But if you store it in a cookie, For example, if you look at my login route, I never okay, you can't see the front end code from here because I'm using this guy. I'm using Postman. But basically, your browser is always going to send the cookies to your back end, so it makes it easier for you. So the answer is yes, you can use local storage, but it's more work because you have to actively be sending the JWT. But if you use the cookies, automatically the browser always sends cookies and receives cookies and stores it, right? So yeah, that's it.
Okay, all right. So I believe that's the last question we have here.
All right. Thank
Okay,
you.
so thank you so much, Emmanuel, for this session. And also, guys, I'm dropping Emmanuel's handle in the link so you can do well to follow Emmanuel on LinkedIn. Or what will be preferable for you, Emmanuel?
Yeah,
LinkedIn
yeah.
or
LinkedIn
Twitter?
is fine. LinkedIn is fine. Twitter is fine as
Uh,
well, but whichever one.
okay, so you can do well to follow Emmanuel on Twitter. Sorry, on LinkedIn rather.
Yeah.
All right, guys. So
All
that
right.
will be
Thank you for
all
having me.
for today. Thank you for coming. We appreciate your time.
Sure. Bye.
All right, guys. So go ahead to follow Emmanuel on LinkedIn and you can ask him questions. I think that will be all for tonight. So good morning, good afternoon, good evening. Bye, everyone.
Bye.
Bye.